Cool. I think we will start in like 2-3 minutes. So if you didn't grab coffee, something sweet down there, you have your chance. You know, like us, but yeah.
I'll just be in the back.
Minute.
Hey, how are you doing? Sorry, what? Sorry, how are you dinner? Well, we have to make it happen, yeah. All right. I'm excited to hear you here. Okay, awesome. I'm excited to give it. It'll be kind of similar, but there's some new stuff. There's some new stuff compared to the. I don't know how I was. Deep fake. Well, I mean, I work in deep fakes. Yeah, that's right.
Cool. I think we can start. Good afternoon, everybody. Thanks for coming. This week, weather treating us much better. My name is Sergey Sanovich. I'm a fellow here at the Hoover Institution, and this series is also sponsored by the Cyber Center, by the CSAC, our next door neighbors, as well as Institute for Human-Centered AI and Stanford Center for AI Safety. And last time we had a bit of a break from research, talking with a startup that's called AI or Not, and talked about the market for this kind of tools. Now we're back to research, but research about the detection in real world. So we are very lucky to have Liam Duggan here with us. He's a PhD candidate at the University of Pennsylvania, and did some stints at NVIDIA and Roblox. Got grants from Google, and as I just learned, from Intelligence Advanced Research Agency, together with his advisor. And I think you also mentioned that some of your research was cited to congressional testimony, and I hope you mentioned that at some point in the talk. So we'll have like 35 minutes, 40 minutes for the talk, and then open up for the questions. You can ask clarifying questions if you have during the talk, and whenever you ask a question, please say who you are. Liam, the floor is yours.
Awesome, thank you. I'm just setting this timer for 40 minutes so I can know how to pace myself. Cool. Here. I have to find where my mouse is. Perfect. All right. So thanks everyone for coming to the talk. Today I'll be talking about
what progress we've made towards potentially actually using AI detectors in the real world, and the sort of remaining impediments we have to actually deploying these systems. But before I get into too much of the nitty-gritty details, I want to start this talk off with a bit of an anecdote from what kind of got me into NLP. So the date is February 14th, 2019, and I'm a undergraduate student in the University of Pennsylvania Computational Linguistics class. This is me in the audience. And my professor, who goes on to become my advisor, is Dr. Chris Callison-Birch. And unlike what was normally planned for the lecture on this day, he instead walks up and shares this to the projector, which is the OpenAI blog post called Better Language Models and Their Implications. So this is the blog post that originally released the GPT-2 language model. And my professor, I'll never forget him saying this, but he said that the company refused to release the largest version of the model due to their concerns about it being undetectable to humans, and their concern that it could be used for AI disinformation. Now, as an undergraduate student, hearing that from a professor, you go, whoa. And then he said something along the lines of, normally when companies do this, the findings aren't real, but if this is real, this is a really big deal. And so I couldn't help but think, wow, this is really cool. I gotta do research in this field. So of course, my first research project is exactly on this topic. My final project in the class, I team with another undergrad, and we write a website for detecting generated text. Just a really quick aside, this is the text that was part of this blog post that was claimed to be undetectable. It took 10 different tries for the model to generate this, and even still, it's a little bit odd. But the prompt is odd, so we'll give it a pass. And so I wanted to figure out whether or not humans actually could detect generated text, or whether the company OpenAI was doing something with the numbers. And so my undergraduate friend and I, we wrote this website called Real or Fake Text. So it's still live at roft.io if you want to go there. And basically what this website is it's a gamified platform to help people determine whether or not they can detect generated text, and hopefully help them train to notice the different signals of generated text and the different tendencies. And the way that the platform works is that we show you the prompt, and then we show you a continuation. And it's your job to tell us whether or not the continuation is human written or machine generated. And the twist to our platform is that every single continuation starts out human written at some point, and at some point transitions into being AI generated. And so if you say that this first sentence is human written, we'll give you the next sentence, and then the next, and then the next, until you think that it's machine generated. And if you select it, you'll give your reasoning as to why you think it's machine generated, and then we'll show you the correct answer. And so you get 5 points if you get the correct answer, and then you get less points if you're sort of close to that sentence. And we thought this was a fun way to test people's ability to detect generated text. And I encourage people who are interested to go try it out, because it's actually quite fun to see. But importantly, we wanted to answer the original research question, which is, can people actually detect generated text? So we actually did a annotation study. This is, of course, in the pre-ChatGPT era. So this is mainly on GPT-2 generated text. But we got over 20,000 annotations, which at the time was the largest ever study of human detection. And the data is publicly available if you want to check that out. And we found that people were really bad. So most of our players had an accuracy of roughly 20% on guessing the exact sentence. The correct side of the boundary was slightly better, but nonetheless, like GPT-2 was able to fool them for quite a while. And this was GPT-2, mind you. We did find something interesting though, which is that people were able to, over time, get better and better at detecting generated text. So we split our population into two sets. One of them, we gave them extra credit proportional to how well they did on the task itself. And the other population, we just gave them a fixed amount. And the population that did have some incentive to get better did get better over time by roughly half a point. So that's half a sentence closer to the boundary over time. And this was really cool. But unfortunately, we also found that as models get larger, they get increasingly human-like and hard to detect, which was sort of well known, but we corroborated it in this study. And so the takeaway here is that while people can learn to detect generated text by repeated exposure to that language model, it gets harder and harder as language models get larger, and that this problem really was not going away because very shortly after all of this, the models got much larger than 1 billion parameter. And we've seen in more recent work, as the years have gone on, that the human detection rate has gotten worse and worse. Now it's basically random chance, especially for people who are not familiar with generated text. And this is actually really spread from text into many different domains, right? We have now generated images that look very realistic. We have generated audio that sounds very realistic. I'll play this for people.
Uno de los castillos más hermosos en la tierra de Azura se encontraba en lo alto de una majestuosa montaña.
Right, very good. It transitions to being English at some point during this audio clip, but I'll save the time. And we also have AI video, which at the moment is still quite noticeable, but is getting very, very good very quickly. And I wouldn't be surprised if it gets to a point where we can't detect that either. And so all of this begs the question, what sort of harms can potentially be brought about by the fact that we can't detect generated content anymore? Like, was OpenAI in their original formulation correct to think that we might want to withhold these models? And so here I have a quick video created by a University of Pennsylvania student, and I'll let the video play, but this is an example of the types of things that can happen.
In GPT and multimodal models, we now have a recent explosion of AI deepfakes, which can generate narrative, video, and audio.
I am not Morgan Freeman. What you see is not real.
I've seen them before, how they impersonate celebrities and political figures, but I never expected to see myself in one of those deepfakes.
很感动，当全世界都在给俄罗斯男看诗，只有你们中国的兄弟姐妹没抛弃我们。俄罗斯的农村真是个奇妙的地方，注视是土豆。
This is not Olga. Her name is April, and she's been living in China for 8 years. She has my voice, my face, and she speaks fluent Mandarin. I kept checking the links, terrified to realize that there's not one, but an army of my clones, each getting thousands of likes and comments. But the worst part of the story still awaited me. I then translated the videos with Google Translate and figured out the most terrifying part. The narratives my clones were voicing sounded like blatant propaganda.
She's saying, I hope the Sino-Russian friendship will last forever.
In the hundreds of videos that I've watched, the majority of my clones seem to talk about how great the relationship between Russia and China is and how much Russia needs Chinese economic support. It seems like the main narrative of these clones is to strengthen the relationship between these two countries, presenting me or my clone as a Russian POV. As a Ukrainian, this has obviously been infuriating for me. After all, my family has to hide during air raid sirens, and hundreds of thousands of my fellow Ukrainians are getting displaced, injured, or killed because of the Russian attacks. And now I'm seeing the copy of myself, my clone, advocating and sympathizing with the Russian Federation.
Right. So, needless to say, AI-generated content can cause many harms. You can get an increase in scientific fraud, AI-generated papers about spurious scientific results. You can get targeted phishing scams. For example, someone knows some personal information about you and can write emails that successfully convince you to do something. Disinformation is a big one, but also impersonation, deepfakes. Spam and harassment, so hundreds of social media accounts potentially all commenting on the same person. Increased social isolation by talking only with chatbots, and then also increase in academic dishonesty in classroom settings. So what do we do about all of these harms? Well, the first thought is maybe we go back to what OpenAI did, and we just shut it all down. We just get rid of all these language models. And there was, to give this point some credit, there was an attempt at some point in March of 2023 to set a pause on all AI experiments until we can sort of better create a sort of safety net around AI content. However, unfortunately, I think that moment has since passed, and absolutely nothing was done. And now the cat is out of the bag, so to speak. Many open source companies, DeepSeek, Mistral, Qwen, Vicuna have released very large and very capable language models that are able for anyone to download and use. And while this is undoubtedly a good thing for research, it may not necessarily be a good thing for the AI safety advocates to sort of stop the harms of language modeling. So needless to say, this is kind of an option that is off the table. So what else can we do? So why don't we just use AI detection? So here's a thought experiment. If we had 100% accurate AI detection, what could we do? Right? Guaranteed AI detection. Well, we could document the scope of current AI usage. We could get a much better handle on the harms that AI is causing and its use in a bunch of these different areas. And we could also have a kill switch. And this kill switch would be out of the hands of any one particular entity if we had AI detection, because at any point, if you wanted to, you could download the perfect detector and you would just get rid of all AI on your timeline, right? And it also allows people time to make decisions. It would allow us to put a pause in our hands and then sort of wait to see what we would allow and not allow. However, it's not that simple because detectors get things wrong all the time, constantly. So if you're a journalist and you get falsely flagged for using AI, you can get fired. If you're a student, you can get given an F with academic dishonesty flag for doing nothing wrong. And these errors happen very, very frequently. Like as someone who works on detection, every so often I check Reddit r/ChatGPT, and you can see one of the top posts is usually, oh, my professor says I used ChatGPT in my class, but I didn't. How do I, what sort of recourse do I have? And there really isn't any. And one thing I want to make very clear is that it doesn't take a lot of errors to have this happen at all. So imagine, my advisor regularly teaches classes of 500 students, and let's say that they have, my advisor is obviously a computer science professor, but let's say, for the sake of the anecdote, that he's an English professor, and the entire class has to submit an essay. If there's 500 students, if you have a false positive rate of maybe 1%, that's 5 students per essay that are falsely flagged as AI. If you have a false positive rate of 0.1%, like your detector is 99.9% accurate, that's still roughly 1 student every 2 years falsely flagged. And in a zero tolerance context, this could be really, really bad. And furthermore, there's been work showing, work from Stanford, showing that GPT detectors are biased against non-native English writers very frequently. And this means that the harms that are potentially caused by detectors may be disproportionate. And so they may affect certain populations much more than others, which is another vector of harm. So it's not as simple as, oh, we'll just use detectors everywhere and then we can shut off all AI. Unfortunately, detectors actually cause harm too. And so fundamentally, what I want to frame this talk around is figuring out how good AI detectors are and in what specific use cases do they solve more harm than they cause, because they do cause harm. And so as a quick overview, I'm going to talk about my work evaluating and benchmarking the robustness of AI text detectors. And then I'm going to move on to some of the work I've done improving the robustness of AI detectors. And then finally, I'll end talking a bit about where I think AI detection should be used. And I'm also more than happy to sort of make this into a broader conversation about the topic. Okay, so moving forward. So the first paper I want to talk about is this paper. This was published at ACL early last year. And basically what we wanted to do is we wanted to, well, first off, so machine generated text, like I mentioned, there's a lot of potential harms. And if you look at the detection literature, a lot of detectors claim to get extremely high accuracy. So 99 is not uncommon to see. There's even detectors that claim 99.98%. And so this shouldn't be a problem. Detection is solved, of course, but the boots on the ground reality is completely different. And so what we wanted to do with this paper was we wanted to create a sort of more centralized evaluation framework for AI detectors. And sort of we wanted to make sure that everyone was sort of evaluating on the same thing. In order to do that, we wanted to create a shared resource. And if we created a good shared resource, then this would reduce the rate of overclaiming by detection papers and under-trusting of those same results. And it would also help to show us which detectors are actually performant so that we can know how to progress the state of the art. So the benchmark we created is called RAID. short for robust AI detection, and it's over 10 million generations from a bunch of different language models in many domains across many decoding strategies and adversarial attacks. And in the paper, we benchmarked the performance of the state-of-the-art detectors, some from each different category. And we wanted to see whether or not the numbers in their papers sort of matched up to what the accuracies we were seeing were. Just as a quick overview, we had the following language models. We had some open source, some non-open source, some were fine-tuned to be chatbots, some weren't. And then we had many different domains. And we also added extra adversarial attacks. So we would edit the text in order to help continue to try to deceive the detector. So the major findings are here. I'm going to go through them one by one. So the first one is that the false positive rate of detectors matters a lot. I was mentioning this earlier, but the false positive rate, so if we consider positive to be identifying something as AI, a false positive would be I'm human written and I get falsely labeled as AI. And this is the source of a lot of the harms of AI detectors. And so it's really important to be able to understand what the false positive rate of detectors are. So I think I can skip this slide because I've already talked about this. But our ideal operating point is here, somewhere in the realm of maybe 0.1%, depending on the context. This, of course, depends on the policy that you want to use for AI detection. But roughly speaking, you want to be somewhere around here. And the modern detectors just cannot operate at this false positive rate whatsoever. So models achieve the sort of a 90% recall accuracy, but only at a similarly high false positive rate of maybe 10% or higher. And then as you go lower and lower on the false positive rate scale, you just get worse and worse accuracy. And the way that we're doing this, by the way, is we'll take the threshold for binary classification and we'll sort of crank it up higher and higher until the accuracy on human text is a certain value, and then we'll evaluate the recall on the machine generated text. Yeah, so currently no models are able to operate at the safe false positive rate. Another finding we had was that detectors were extremely brittle. They performed very poorly on unseen generators and domains. So really quickly, a decoding strategy for a language model is just the method you use to sample the next token. So you can either sample the most likely token, or you can sample randomly from the probability distribution of the language model. And then furthermore, you can add a repetition penalty if you want, which downweights the probability of tokens that have previously been generated in the context. And these things actually change the output style of language models pretty drastically. And the detectors we tested really failed to generalize across decoding strategies. So even with the exact same prompt in the exact same domain, if you added a repetition penalty and random sampling, the accuracy could drop by upwards of 50 or 60%. So you could go from a classifier that looks very, very accurate if you only tested it on when the model picked the most likely token, to suddenly being barely able to do anything at all. And furthermore, many detectors fail on particular generators and domains. So a GPT-2 classifier is very good at detecting GPT-2, but as soon as you move out of that model, suddenly it does much worse, even if it's from the same model family. And then also certain detectors do really poorly on some domains. So the radar detector did really badly on movie reviews for some reason, and every other domain was fine. And so if you combine these two things, both the change in domain and the change in decoding strategy, seemingly strong detectors can fail catastrophically. So we can go from outputs with GPT-4 with greedy decoding, getting 100% accuracy, to outputs from Llama with random sampling and repetition penalty being basically 0% accurate. And this is while maintaining the exact same domain. This is just news articles. And the final thing is that adversarial attacks are also very effective at fooling detectors. So just as a experiment for everyone here, the left text is the original text and the right text is the text that we altered. Can anyone see what the difference is between those two? Yeah, I heard someone said the space characters. So we added 3 space characters. And if you notice this, you might also be interested to know that this causes roughly a 15% reduction in accuracy on average across all the detectors we tested. So certain detectors were even more susceptible to this attack than others. We also tried a bunch of different adversarial attacks, like I mentioned. We have uppercase, lowercase swap, white space, article deletion, synonym swaps, paraphrasing, misspelling, and then homoglyph attacks, which replace certain characters with other Unicode characters. And each of them had their own average performance drop. And interestingly enough, the paraphrase was actually the least effective adversarial attack. And some of the attacks on the tokenizers were significantly more effective at fooling detectors. So it seems like unless you're sort of explicitly training in a more robust fashion, these sorts of attacks allow you to fool detectors pretty easily. Okay. But what happens when you do know about all these things ahead of time? So what happens when, if I say, we're going to test you on these domains, these models, and these adversarial attacks, then how well can you do? And I think this gets at the heart of the issue in the detection literature, where we see all these really high performance numbers, and then the out of domain performance is so bad. And the sort of reality is that many people are getting accused of using AI when they're not. So we noticed shortly after publishing the RAID paper that there was going to be a workshop on detecting AI-generated content at the upcoming Coling conference, and that they were hosting shared tasks. So we decided to submit a proposal for a shared task for people to train on the RAID dataset and then evaluate their detectors there. And we thought that would be a good way of showing how good you can get if you have all of the models in domain. So I'll talk about the results from this paper here, the results of the shared task. Our main research questions are whether or not a single detector can be trained to detect text from many different domains and LLMs accurately, and then whether or not a detector can be robust to many different known adversarial attacks. So the shared task ran from September 18th to November 2nd. We had 9 different teams, and they submitted, I think, 21 detectors, somewhere around that. And then during the second phase, we evaluated all of the submissions, and then finally, we wrote the summary paper during the final stage. Subtask A was the non-adversarial, and then subtask B was the adversarial task. One thing that's really important to note before I keep going is that the actual RAID benchmark is really, really imbalanced. So for every human document, there's one document generated by all of the different AI language models. And so what this results in is there's like a 40-to-1 imbalance of AI to human text in the data set. And this gets even worse when you do adversarial attacks, because we apply adversarial attacks only to the AI texts. So it's really, whatever 40 times 12, it's a very large number, 480-to-1. And so in order to compute evaluation metrics, you can't just use accuracy on this, because you can just guess all AI and then you would get very high accuracy. And so the metric we used is the same metric as before, but to a fixed false positive rate of 5%. So that's how much AI-generated text you correctly detect while maintaining a 5% false positive rate. And this is straightforward to calculate. You just run the detector on the human text, tune the threshold to 5%, and then evaluate the recall. We also give the participants access to all of the code for the adversarial attacks and the source domains for the human text. So they can generate as many adversarial examples as they want, and also had access to as much human text from the original domain as they wanted. Domains being either news articles or recipes or short stories, stuff like that. Okay, so what were the results? On the left, we have the results for the subtask A. This is the best submission from each team on ranked. And then on the right, we have the best submission for subtask B. So our top 2 teams got 99% TPR for non-adversarial, and then adversarial got 97 TPR. And this beat the previous state of the art by quite a lot. This is very unexpected for us, because we thought that RAID was this very difficult benchmark that would really sort of stand the test of time, and then basically people beat it immediately. It's worth noting that the baseline is widely considered to be the state-of-the-art unsupervised model. So this was beaten by pretty much most of the teams. The ones that didn't beat it also were unsupervised. So takeaways on the results of the task. So like I said, the RAID dataset was supposed to be this final boss of a detection dataset, right? There's 10 million documents from as many language models as we could possibly run on an academic budget, and yet it was beaten pretty easily. So we looked into the RAID dataset, and it's not to say that there's no flaws, right? Like there were shortcuts that models could take advantage of within the dataset, like regular occurrences of new line characters. There was also instances of meta commentary where you ask a language model, generate me an essay, and it says, sure, I'll generate an essay before generating the essay, which makes it very easy to detect. There's also certain texts that were repetitive or sort of degenerate in some way, like the model just outputs the same token over and over again, but this mostly happened in the older models and on greedy sampling. But still, I think it's really impressive that when you give detectors a fixed set of models and domains, they do quite well. So for our original research questions, like given the context of the flaws of the RAID dataset, I'm going to say a bit of a maybe. But I think that there's a lot of evidence to support this claim that like detectors do very well in domain. The takeaways for me, at least, is that we definitely need to find a way to build harder benchmarks, at the very least filtering out text with shortcuts and increasing the diversity of text, but also we want to have more held out domains and models so we can actually get an idea of what happens when you train on, say, n models and then you evaluate on n+1, n+2, n+3. So that's the end of the first part of the talk. So I think a reasonable takeaway from that is that in domain is relatively easy and out of domain is extremely hard, and adversarial is pretty much impossible unless you know the attacks ahead of time. But I'd like to move on to what we've been doing to try to improve the robustness of our AI detectors, and specifically focusing on this AI-generated multimodal content on social media. So the next paper I'll talk about is Mirage News, and this was published in roughly, I think, October. So here's the problem that we're trying to tackle here, like I said, is this sort of AI-generated misleading news content on social media. So imagine a sort of tweet like this, but the image is generated and the caption is generated by AI. This is specifically news content that is inflammatory and misleading. So it's not just any arbitrary AI-generated image, but we wanted to focus specifically on cases where AI is actually causing harm. And so to evaluate and train detectors to do this task, we created the Mirage News dataset. And so this consists of 12,000 news image caption pairs. The real news images and captions come from the Terra dataset. It's from New York Times. And the fake images are generated by Midjourney. And the way that we generate the dataset is we first take the real news image and caption, and then we ask GPT-4 to rewrite the caption to be a sort of harmful version of the same caption, but maintaining all of the different signifiers of the original caption. So if there's an entity, we want to keep the entity in the new text. And so we do a check after we rewrite the caption just to make sure that it's still semantically the same. So we want to have like Tuesday is still there, vegetable market is still there, and then Zhengzhou, China is still there. And so we want to have sort of the minimal pair of what is the harmful version of this caption, and then we pass the caption to Midjourney, and it generates the headline image for us. So we now have paired captions.
And GPT-4 didn't object for this.
It did vociferously, but every time it objected, we just said, okay, we'll sample a new pair. But it took a while for us to sort of engineer the prompt to be able to do that. And lucky for us, we did this early enough where they were not as good at sort of fooling us as they are now. Okay, so after the study, we wanted to make sure that these were actually convincing and undetectable to humans. And so we did another human study. So we took 112 students in the graduate level NLP course. This is my advisor's course. And we randomly assigned them 20 image caption pairs each. And they were asked separately to determine if the image is generated, and then also if the caption is false or misleading or inflammatory. And students had 60% accuracy on detecting whether or not the images were generated, and had 50% accuracy roughly on whether or not the captions were fake or misleading, which is really, really bad. So at the very least, we can say that the data set is of acceptable quality to be a reasonable test case for these detectors. So now, how well do classifiers do? And so the way that we wanted to evaluate this is we wanted to train a classifier ourselves and then also evaluate other state-of-the-art classifiers and fine-tune them on our data set. The classifier we ended up going with is the initial one is very simple. So we just have a clip encoder for the image and a clip encoder for the text, and we pass those embeddings through a linear layer, and then we combine the predictions at the very end. So this is pretty much the first thing that you would think to do if you're trying to do this task. And it did really, really well. So our classifier did 99% accuracy, and then the other state-of-the-art detectors that we fine-tune on the data set also did fairly well. Deepfake specifically is just an embedding that we froze, and so the accuracy didn't do as well as the other models. But I think that this also is another piece of evidence for the in-domain task is very easy. But now the question is, how well did these classifiers do out of domain? Because we don't always know the generator, we don't always know the sort of the domain of the image. And so in order to evaluate the out of domain performance, we created 4 additional test sets with 500 pairs each. So for each of the test sets, we either varied the original source of the news article or the generator. And so we had one set that was BBC News with DALL-E 3. We had one set that was CNN News with DALL-E 3, and then the same for Stable Diffusion. And so all 3 of those image generators are sort of collectively seen as the state of the art, although Midjourney is occasionally better than the other 2. But that's subjective. Okay, so the same classifier that we trained did significantly worse on out of domain, although it's not nearly as bad as some of the RAID dataset results. But admittedly, in the RAID dataset, we really tried very hard to fool the detectors. And in this case, it's simply the exact same domain, but just a different generator. And the accuracy is much worse. And so this is a problem, and we would like to do better out of domain. So how can we improve the robustness? So one thing that we can try to do is think about when you're a human and you're detecting whether or not something is generated image, what sort of things do you look for? So this is kind of the intuition we started at. So what I tend to look for is I try to look at the faces of the people and try to see if there's any sort of artifacts there. I also tend to look at the hands and then also other like body parts like legs and stuff. To see if there's any sort of inconsistencies there. I know that AI generated images tend to have like, 6 fingers or 4 fingers or something like that. And at least subjectively, I've seen that this is common across many different AI image generators, that a lot of them make similar types of errors, that there are certain things that are difficult to generate just because they are difficult to model, fingers being one of them, people in the background being one, so on and so forth. And so using this intuition, we can try to make our detectors more robust. So the key idea is that certain objects may be hard to generate across all generative models. And so what we can do then is we can take an image detection, an object detection model, and we can classify regions in the image that are of a certain object type. So whether there's human heads or let's say plastic bags or something, and we have like a fixed list of maybe 200 or 300 of these classes that we look for in every image. And then we train a separate classifier for each of these different classes. So we want a classifier that tells us whether or not a human head is AI generated or whether or not a plastic bag is AI generated. So these predictions have completely separate classifiers. We have 300 of these classifiers, and then we combine all of their predictions together in the output. And we can do the same for text actually as well, although it's a little bit less intuitive. If we take a caption, we can have a large language model generate different questions about the text. So we can say, does the text employ sensationalized language? Are there other like violent actions or behaviors depicted in the text? And then we can answer each one of these. And then we can combine all of those predictions. And in some ways, this helps us get not only a more interpretable model, but it may also improve robustness. So we wanted to see if this would work. And then finally, we can also, right. So yeah, so the full Mirage detector is taking the initial embedding model and then also doing the bottleneck model in the same way. Bottleneck being this sort of classification task, right? And then we combine the predictions for both the image and the text side at the very end. And we see if you add the bottleneck features to the Mirage classifier, it does slightly worse on in-domain data, but does slightly better in out-of-domain performance. And this is to be expected somewhat, because adding more sort of bias into the model may not allow it to sort of, overfit might be a strong word to use, but maybe not allow it to learn the in-domain data as well, but it may allow it to learn features that are more generalizable across different detectors. However, the effect size is pretty small. This is primarily due to the fact that you have to decide the classes ahead of time. So we decided what we thought would be the most likely objects that would indicate that something is AI generated, but that might not be the case. It might not be the case that plastic bags were very indicative across all models. So we do have a decent amount of faith in this technique, but I think future work needs to figure out how to automatically detect which objects are the most sort of discriminative across lots of generators. Okay. Same takeaways. I think we're still very far away from robust the cross-domain multimodal detection, but the concept bottlenecks might be an interesting direction. So the final thing I wanted to talk about is a really recent result. This was put on arXiv maybe 2 weeks ago or so. This work tackles the question of, if detectors are going to make mistakes anyway, then can we at least make sure that they don't do so disproportionately? So this comes on the heels of, so this is, this is the paper, it's in submission to ICML at the moment. But this comes on the heels of this work that shows that sometimes AI detectors are biased against certain groups. And this is actually a really difficult problem to solve, because all machine learning models are biased, because features that correlate with your predicted class will have correlations in the data, and it's very difficult to balance these things. So detectors can be quote unquote biased across many different types of categories, right? Like maybe AI always outputs very long text, and so if text is long, detectors are more likely to flag it as AI. Likewise, image resolution or even the tone of someone's speaking voice might be something that the AI uses as a feature in detection, but may also lead to bias. Like as a thought experiment, for example, say you have 2 different narrators for an audiobook company. Person A has a deep voice, speaks informally, and has really bad mic quality. And then person B has a relatively high voice, always speaks very formally, and has very good mic quality. Which of these 2 people are more likely to be falsely flagged as being AI? And I think it's clear to me that it would be person B, because AI tends to have very good mic quality, speak rather formally, so on and so forth. Right? So person B might just get fired, and person A might not. And this is pretty bad. And we would like to be able to have AI detectors that are deployed in the real world be fair across these sorts of categories, that the harm is not sort of disproportionately concentrated on any one particular group. And so the idea here is we want to require the model to be extra confident for certain groups that we know a priori are at risk of being falsely flagged at a higher rate. So what we can do is, say our classifier outputs a number from 0 to 1, where 1 indicates maximum confidence about AI, and 0 indicates maximum confidence about human. If person A, we set the threshold to be something like 0.5. So if the AI gets higher than 0.5, we say that this text is AI. And then for person B, we set the threshold much, much higher. And note that we can't identify that something is coming from person A or person B. What we can do is we can classify whether or not the voice is high or deep, whether or not the speech is formal or informal, and whether or not the quality of the mic is good or poor. So based off of those features, we can tune the threshold appropriately. So if I see that the speech is informal, I'll make sure to have the threshold lower than I otherwise would if it was formal speech. And so how do we evaluate the fairness? There's a very simple metric for this, which is the demographic parity, which is the difference in probability of a positive classification across all of the groups. So if you're in group A, the probability of you getting labeled as AI should be identical to if you're in group B, or at least as close as possible to that. However, if we have many, many different categories, you get the curse of dimensionality, right? So text, long, short, formality, informal, formal, sentiment, positive, negative. Suddenly you have 16 different classes, and you want to make sure the positive rate is balanced across every single one of these classes. This gets to be very unwieldy, and it's very hard to actually find the optimal solution of thresholds for each group that satisfies the fairness criteria. And so what we did in this paper is we treated the problem as an optimization problem, and basically did gradient descent on the thresholds. So we iteratively go through and perturb a set of thresholds in the direction of the gradient of loss, which is accuracy plus the fairness metrics. And so we have certain thresholds. If the accuracy is over a certain amount and the fairness is over a certain amount, then we return. Otherwise, we continue to step in the direction of the gradient for each of the different thresholds. The algorithm, when we run it, it improves fairness, but it also interestingly improves accuracy sometimes, because in comparison to a fixed threshold that is tuned to a one-size-fits-all false positive rate, if you allow the model to have different thresholds for different groups, some of which are more at risk than others, then the model can actually tune it separately and may result in higher accuracy. So this technique is not only good for fairness, but it's also occasionally good just as an accuracy improvement. And this can plug into any modality. It doesn't necessarily have to be just text, but we happen to do it on text in this case. Okay. So the takeaways is that fairness is not just accuracy, it's important to consider, and that unfair detectors cause disproportionate harm. And finally, that classification thresholds are useful for balancing fairness criteria. Okay, so to recap, closing thoughts. I know I am slightly over time, but hopefully I'll be allowed to end with this. Okay, cool. So like I mentioned, I think one of the main takeaways from all of the work I've been doing is that out of domain is really the main area of challenge, right? We have across models, across domains and adversarial contexts, detectors are just really, really bad. And I also think it's just very interesting at how good detectors are at in-domain data. So most tasks are challenging in their own right without needing out-of-domain samples. But it seems like no matter what we do, no matter how many models, no matter how many domains we sort of evaluate across and train on, that all of the detectors seem to just do really well. And I think this gets at, again, the core issue in a lot of the detection literature where, say, companies say that their detectors are 99% accurate, and then we get overconfident and we use them in real scenarios, and then they cause harm. I think that the concept bottleneck approach might be a good way to improve cross-domain robustness, as well as just getting a lot more training data, which is always something that will improve robustness. But I think we still have a long way to go, and I'm hopeful that there will be modeling techniques that help bridge this gap. And then again, detectors may also be very biased just due to the nature of their training, and we should also make sure to correct for these biases when deploying detectors in certain contexts. So now I'd like to end with some musings on where we can actually use detectors in the world right now, because this is something that's been on my mind ever since I was involved in a university tribunal case where a student was arguing that the detector was falsely flagging them, and there was pretty much nothing anyone could do on either side to prove whether this was true or not. And so the student got off scot-free. I have no idea whether they did or didn't use it, but if you can't really prove anything either way, then what are we doing with this detection endeavor?
Presumption of innocence.
I mean, well, but right. That's the question, right? So this is warning. This is just my opinion. This is not necessarily based on concrete experiments. But I'd like to think about if there are other ways to mitigate the harms of generative AI models that I mentioned at the beginning. So let's take the case of AI-generated product reviews. Like, it may be possible to use an AI detector and flag all product reviews that have over a certain threshold, and then let's say get rid of them or ban the accounts or something. But that could potentially be very harmful to sort of small creators on Amazon. But what else could we do? We could also probably just look at if all of these accounts are following the same people and always reviewing the same products. Amazon has good security where they say, if you haven't bought the thing, you can't review it. I think that probably weeds out a lot of this. So maybe AI detection isn't actually necessary in this use case.
I think I heard from people, it doesn't. People buy it just to leave a review, and there is like a system for that.
But I just mean that there may be many other potential signals that you could use, right? That may not involve AI detection at all. And then likewise with misinformation, it's not that we're trying to classify whether this is AI. We really don't care that it's AI. We care that it's misinformation, right? So should we actually be classifying the factuality of the text rather than the AI generatedness? Because in fact, AI can be used to generate plenty of true things, and that should be fine. And then furthermore, there's also community notes are a decent way to combat misinformation, although at scale this probably breaks down. But there's many ways to do this that aren't AI detection. And also, poor implementation of AI detection has free speech implementations. Like, let's say, for example, you downweight all of the tweets or websites that you think are AI, and then certain people just never get seen in the algorithm. This is very bad. And then finally, in the case of students, it may be the case that AI detection is the only thing that we can realistically use. There may not be other signals. But maybe we can just restructure our classes to sort of take impetus away from long take-home papers and maybe more in-class discussion, things like that. Because the trade-offs are that certain students may get flagged for academic dishonesty and then have to go through an onerous sort of tribunal process where they will ultimately be acquitted, but it's still a huge headache. So I don't know. These are the sort of questions that I've been thinking about. I'd be happy to hear thoughts. I do think that in the case of news images, it's very obvious that we don't want AI-generated images. We want real images. But in this case, this is AI detection at its cleanest. I think there are definitely use cases where there's not many other features you can go off of, and you really need to just do AI. And so I guess my sort of takeaway currently, where my thinking is at, is that it might be the best to use detectors in conjunction with larger systems where there's many other different features that you can condition on in order to reduce harm most effectively. Because ultimately, at the end of the day, we're not really trying to detect AI or not, we're just trying to reduce harm. So anyway, that's about it for me. Sorry for running so far over time, and thanks so much.
We have, I think, enough time for questions as well as comments. So who wants to start? Yes, and say who you are.
Hello, so you didn't touch on this in your talk, but I'm thinking if you touched about like preparing for like a task that you know about, but when you release a detector out into the wild, and say you're using it everywhere, then like anybody has like all of the, with some resources, like they can like use it all they want to try and optimize against that detector.
Yeah,
we actually talked about this in a previous talk. So in that case, like what do we, your detector is going to need to be robust against like any type of say other malicious agents trying to collect training data on your detector to optimize against it. So what do you think we can do about that?
Yeah, so just to echo this, like the core problem in detection is that it's heavily asymmetric. Whereas if you are a detector, if your detector is publicly available, there are certain ones that aren't and are request only. Maybe that's the only way to go forward. But ones that are available,
OpenAI, for instance.
Right, for example. But if your detector is publicly available, then I, as the adversary, can query you as many times as I want. In the RAID dataset, we limited ourselves to no queries whatsoever of the detector beforehand. We just thought, here are some adversarial attacks that might work, and we did them without doing any sort of query-based adversarial attacks, and we got strong results even without it. So all of that leads me to believe that the case that you mentioned is pretty much impossible, which is bad because the people that would be causing the most harm and have the most to lose would be the most invested in avoiding AI detection. It's the exact thing that we would not want to happen, right? So I really don't think that there's a universe where we can be robust to all possible adversarial attacks. If that happens, it would be very far in the future from now. So I think that the key would be in that case to detect the actual harmful content in the speech itself rather than it being AI, right? So detect whether something is factual, whether framing is misleading. There's a bunch of different NLP tasks that you could come up with to do. And maybe if all of those classifiers together all point towards one thing, it's kind of like the airline, Swiss cheese model, where you have a bunch of different things, but none of them actually line up so that there's one failure. So, yeah.
Yes.
Thanks so much for the talk, Liam. I'm really interested in how you think about scaling, because it feels like there's the potential for like an arms race, right? Where as the models get better and better at generating realistic images, video, text, the detectors have to kind of constantly keep up and are constantly a step behind. So like, what's your view when you're looking 1, 2, 5 years into the future on some of this?
Yeah, so this is a great question, and it's something that I was a lot more worried about maybe 2 or 3 years ago than I am now. And that's precisely because I kind of thought that once, and I'll speak primarily about text, that once we got to say, GPT-4 or 5 or 6, maybe even, that detection would become increasingly impossible. But actually, it seems like a lot of these companies have been training their models to behave like very specific personas as chatbots. And it turns out that those personas have very distinct styles, like ChatGPT overuses the word delve or something, or the chatbot is always somewhat formal, somewhat polite, and whatnot. And this is not how base language models are at all. You can prompt a base language model to do anything. But I think it's by virtue of them training their model to be sort of constrained heavily, that they've actually allowed detection to become a lot easier. So it turns out that you can detect chat models way easier than you can detect non-chat models, and that sort of gives me hope that we will probably always be able to detect generated text at the very least. As for images and videos and speech, I don't know whether or not models will have a particular distinguishable style, and I don't think that we've seen enough to indicate one way or the other. I'm happy that it seems like detection is possible now, but it may be the case that similar to text, like that non-specifically fine-tuned models that are just base models for image generation might become undetectable in the future.
Yes, sir.
Just a quick question on that. You mentioned in domain is far more accurate than out of domain. By in domain, you meant the detector knows this is ChatGPT generated content versus DeepSeek generated.
That's right.
So is it not possible to do like 2 stages of detection? First, some kind of a detector that figures out what is the likely source of this, and then use the in domain detector?
Yeah, definitely. There's absolutely models that try to do that. The problem is that the classification task of determining what the likely source of the model of the text is actually just the detection task, but a bit harder. So it's like, instead of doing binary, you now have multiple classes. And maybe it might be the case that if I have low confidence across a couple of models, then I'll take the detector that's really well fine-tuned to each of the models that I have low confidence over, and then that will help me determine the final prediction. So that definitely could work, but that sort of presumes that we know all of the models in advance that could be seen by our detector, which is definitely not the case, and especially not the case given the myriad ways that you could fine-tune a language model on some other corpus of text.
Consumer point of view, if there are 4, 5, 6 different models that have most of the market share, you
Yes.
could just worry about them, right?
Yeah, exactly. And I actually think that that's a really good way of sort of going about it. Like if someone wants to fine-tune like Llama 370B on Shakespeare or something, then that's fine. We're not going to be able to detect that. But at the very least, we can get default ChatGPT decoding strategy and default Gemini and so on and so forth. And I think that most detection companies are really focusing on that and just getting a ton of data for that. I think that's reasonable, and we probably would get pretty high accuracy in catching the low-hanging fruit. Yes.
Sorry, 2 questions. The first one is like, does it make a difference in the country? For example, because if ChatGPT is in the US, how color is spelled in US versus in UK is different. So will a country make a difference when you're detecting things like that or not?
I'm not sure I fully understand your question.
Like when ChatGPT is generating a text in US English, they spell color as COLOR versus in the US. In UK also, it'll still do the same thing. You'll not do COLOUR.
Yeah. I'm so glad you asked this, because this is actually one of the adversarial attacks that we implemented, where we had a dictionary of US spellings to UK spellings, and we swapped all of the spellings in texts, and we saw how well the detectors did. And the accuracy drop was roughly 10 or 15% on just swapping to UK spellings, doing nothing else, because the training data was all English text, because language models tend to output English spelling. Now, admittedly, it's a bit mean, because if language models don't output UK spelling, then us doing this adversarial attack is of course going to fool detectors, because they see using UK spelling as a very high indication that you're not ChatGPT, right? But detectors probably shouldn't do that, and we should probably make it a little harder to avoid them. But yeah, that absolutely happens. And so it's another one of those dimensions you have to be robust to in practice.
Let me quickly ask a question on multimodal detection. So easier to, you look at it, right? You add information, you add the chance for one of the models used to make a mistake, but the end result is it's no different from text. Like it's not easier. So looks to me like a little bit of a puzzle.
Yeah, I really expected the same sort of results when I was working on Mirage News. And I was, working with a master's student, and he ran the experiments, and I was thinking like, okay, image and text, there's more information, so it would be higher accuracy. But it wasn't the case, and we reran the experiment. It was the same result. It's roughly the same. And I think this just speaks to how tricky the detection task tends to be. Like, again, if you're familiar with the style of a language model, you'll be able to detect it really well. And if you're not, you won't. And no amount of extra information there sort of solves that problem. And also fundamentally, like, I think it's difficult to, I I think it's difficult when images and text may not both be generated, right? But one of them might be AI generated, and then the caption is written by a human because it's the prompt. And now features that you see from the image might not actually be predictive for the text. So yeah, it's complicated. I experienced that too. It was odd.
Sure. Yes. Yes.
Yeah. So thanks for the great talk. So the way I understood is right now you're mostly talking about detecting fully AI-generated text versus, let's say, AI-generated text that was then slightly modified by humans. I would imagine there's a huge gray area, which especially in academia or in high schools where you have students which first have like a sort of general draft being generated by whatever model they're using, and then maybe spend like 5 or 10 minutes just slightly fine-tuning it. Do you have any quantitative sense in to what extent that's still detectable?
Do I have any quantitative sense? I know that there have been papers specifically on that, trying to detect the specific spans of text that were edited by humans, and there was some success in what is normally very easy scenarios. So like, let's take ChatGPT, and it's only outputting the most likely token, and so we're very confident that something is AI generated. In these sorts of settings, normal AI detection is super easy. In these settings, if you start to edit the text, then we may be able to detect you. But if you ever get into a sort of realm where AI detection is difficult in the sort of easy case, and then you start to edit the text, then I highly doubt that it's possible to detect there. So I guess the real answer to your question is it's easy if the original detection task is easy, and then we have some ability to do it. But no, it's a relatively understudied part.
Yeah, I think that's what would trouble me the most, especially when you have these scenarios where students are getting some sort of sanctions for using or sort of furtively use of fully AI-generated text, but maybe they were only partially using it or whatever. Like it gets tricky really fast.
Yeah, I've seen work on human-written AI-polished text, which should be very different from fully AI-generated text in at least the academic context, because the student wrote this essay and then just wants to sort of clean up the grammar, right? And sometimes that gets detected as AI-generated, which is really bad. So yeah, getting more into the sort of hybrid nature of detection in practice makes all of these questions even more difficult. So again, I keep coming back to maybe other things in conjunction with detection might be the best. In the easy cases, it's easy, but there's so many things that could go wrong.
Well, on education, we didn't talk. I think this is one of the sort of most prominent use cases, but we didn't talk that much about that in our seminar. And given we have an actual computer science student who's teaching undergraduates, so if it's not an English professor, if it's a CS professor, in that case, you just need the code that works. And if it's Copilot, that's fine. But like, how then you evaluate the students?
Right. Yeah. I mean, it's interesting because AI code in the real world, we really don't care that it's AI as long as it works well. But in academic context, we really care that the students are learning, or at least presumably. Like, well, yeah, let's say we very much care that the students are learning. So I think that there was something I was going to say, but I actually forgot. Let me see if I can remember. In the case of AI-generated code specifically, if you wanted to, you could, I think, train a fairly reliable detector if you had all of your assignments from the previous 10 years, and you're sure you can get something that is all Copilot written. I think that that's still probably a reasonable option to get the people who are the sort of the most egregious possible, complete my entire assignment with Copilot. But again, as the technology is advancing further and further, like you really can't keep up well. But you can't also have students just sit in the classroom and write code live in front of you. Maybe you could do oral exams on like a whiteboard or something.
Well, my understanding is that like if you do like international competitions for like Olympiad style, they do it live, like on a blank laptop, right? So
right. But I imagine you could still use an AI to complete some of these problems, right?
Well, I think they're not supposed to, but I'm not an expert. But at least English professors, would be relieved that it's not just their problem.
Definitely not just
that. Other questions? Yes.
Yeah. So towards the end, you briefly mentioned like your opinion about where detectors should be used, should not be used, and I was just wondering if you can elaborate on. You talked about like how detectors might be useful in systems, like what types of systems might detectors be useful in? What will they look like?
Yeah, so at the moment, I think where I'm at in this question is kind of like if I had a system where I looked at the sort of network dynamics of let's take a use case of social media accounts that are sort of all promoting the same narrative, and I noticed that there's 20,000 accounts that were all created from the same IP address that all talk about the same thing, that all follow the same people. And then I also have an AI detector that says that roughly 85% chance of being AI. Then I can be fairly confident in sort of labeling them as bots. Whereas if I just had the AI detector at 85%, I could be totally misfiring on a bunch of sort of innocent accounts. And so that's the sort of case I'm thinking about. But not all problems are sort of easy like that. And there's also plenty of ways that you can get around something like this. So imagine if I had accounts that autonomously looked at their, let's say Twitter feed, and based on some persona decided to like or retweet other tweets that came down the line, and they all acted like independent personas, and then suddenly they all tweet about the same thing. Like in that case, there's very little you can do. So I think just having like as many possible vectors for the same harm reduction as possible is the best approach, but it's not to say that it's a bulletproof approach. I would love if we had perfect AI detection.
I have a couple questions on models, on model detection.
Mm-hmm.
So first of all, you mentioned that idea that they have personalities, and what challenge then open models present in this context? Like if I download DeepSeek on my computer and then fine tune it to be something completely idiosyncratic, right?
Yeah.
So that's one question. And then you also mentioned that, the difference between binary task, whether it's AI or not, or multi-classification of like which model it is. It's an interesting question. I don't know how computer scientists think about it, but I'm a political scientist. I think in social science, it's usually more accurate when you have like multi classification with multiple options, because you can be on the border between two of them, but you clearly not like the third one. Mm-hmm. Or like it sort of moves you in certain direction. Whether when with binary, it's like if you're at 55%, like what it means. Right. So why then you said I think it's easier to do binary. So and like most detectors do binary. So yeah, can you talk about the models?
Right, from like a computer science intuition standpoint, it would be easier as like a modeling task for binary, because it's just extra information, right? You not only have to predict that it's AI, but which AI it is. But I have seen recent results that in the sort of, again, I talk about like the easy case, but it's like fully AI generated default decoding strategy, simple prompt, that it's actually very accurate. That language models have very specific idiosyncrasies. That really indicate whether something is generated from Claude or Gemini or ChatGPT with very high accuracy. It's harder, but like only minutely slightly harder to detect different models. It's like nothing compared to the actual difficult problems of detection, which are all of the things we've been talking about.
And you think with open models it will also be possible?
So with open models, I'm sure that if some of them are like instruct tuned or something, you use it as sort of default, that they're easy to detect because they have a particular style that they've been fine tuned to have. However, if you fine tune the model yourself, I don't think the technology will ever be to a point where we could detect something like that without data knowing ahead of time. Let's say I have all of the poems of Ernest Hemingway, and I trained DeepSeek to be Ernest Hemingway. There's nothing we're going to do about that, unfortunately.
I see. Yes.
Where do you think the future of AI and the possibilities for misuse will be? Especially as my understanding is that AI is only as accurate as information that is provided. And at this point, I feel like AI is at its infancy state, and it's just getting more and more sophisticated at a rapidly increasing rate. So where do you think AI, the direction it's going? And I feel like we're almost in a the world of the Terminator, right?
There are times,
And-
right, where I relate to that.
And how it will become possibly almost self-aware, right? As it increasingly becomes more accurate and more sophisticated, how do we detect it? And how can it, I guess, affect the need for human intervention? I even see AI used in writing and art. So what are the possibilities and how do we detect it and prevent abuse and misuse?
Yeah. So first thing, I'll start off and just say that like all the things I'm about to say are just purely just opinion. Right? This is not hard research facts.
Okay.
But the first thing is I really don't think that AI is going to be like self-aware or anything like this. I think it's sort of generative, and it sort of models what's put in, and it's input output function. Like I don't think there's anything more going on than that. Some people might say differently. But in particular, like I think that as AI content becomes more and more prevalent and potentially more and more sophisticated, I think the value of creativity and other sort of really creative off the wall thinking and writing and sort of art is going to become more and more valuable. Like I think that everyone that sort of interacts with AI content is going to sort of slowly but surely develop some sense of AI literacy, some feeling of, okay, this is the same thing I've seen more over and over. It's the same amalgamation of the same concepts, and they'll really start to appreciate very, very sort of unusual or very creative outputs. So I think for me, at least, that's kind of where I'm feeling going forward. As for what we can do to sort of reduce the harms that I mentioned specifically, like even just being aware that this sort of thing happens and can happen to you. Like I've been fooled by AI images on Twitter before, and it's a very humbling experience as someone who works on detecting AI images. So just being aware that AI is probably more prevalent than you think, because it's quite good at fooling humans. And just sort of being familiar with the sort of style of AI and sort of, I think also one more thing to add to that is trusted sources for information, for factuality are going to become even more important. Like I definitely wouldn't be reading any news article that isn't from a source that I super duper trust because it could be generated by AI. And so I think just going forward, if we can't do detection in a reliable way, which in the sort of hard version of the problem, we definitely can't, that focus on trusted sources and then also real, like genuine creativity. And I don't think AI is anywhere close to a really, really good human writer.
Yes, any other questions? Yes. Yes.
So we are in the first innings of AI, it's a co-pilot. If you go to the next inning, which is the agents, where you're going to let AI do what humans do. For example, I can get an OpenAI agent on my laptop or Claude and let it do things for me, which is the next thing, kind of a thing. So is there any research to detect like when humans are doing something versus AI is doing something, agents? So how do I detect like whether agent did some action or like go to my bank account and transfer money versus human doing it? Like I know
Yeah,
now do everything.
that's a really interesting question. I don't think I've seen any research on like, for example, like the network dynamics of AI agents specifically, and if you can detect it from like a set of actions that the bot took, no text whatsoever. It's just here the set of actions, and maybe the human opens web page, closes it, opens another web page, closes it, checks Twitter, comes back, and then buys the plane ticket. Whereas the AI agent just specifically goes here, clicks button, buy ticket. I don't know. That would be really interesting research direction.
Well, I think that part is something I was thinking about when you showed this video of this lady talking about her avatar working as a Chinese propagandist, Russian propagandist in China. This is like the economics of that is not clear to me, because in real life, when RT was kicked out of YouTube, they did go to TikTok, and they have beautiful Slavic women working for them, and who bothered to actually learn Mandarin, and they did exactly this kind of propaganda about like eternal friendship between Xi and Putin, and between Russian and Chinese people, and so forth. And why is it like and apparently it was pretty successful as far as they do high quality content. So why they needed, in addition to that, to steal an image of a Ukrainian lady to do the AI stuff is not exact. And if I were an RT anchor, I would be concerned about my job security. They were already kicked out from some platforms, and if they would be replaced with AI on others, like what they will do. Cool. I think I think your question on the quality of the training data and so forth. Oh yes.
On the video. So when I was watching, I thought that it will end up with confession that I'm also AI generated. Something I always do.
I was waiting for that same thing.
Yeah.
And Maddie, who was sitting right there, does a lot of AI fake videos, and I was like, yeah. But her ears were moving right there.
So there was a bit of disappointment, right? But I got some questions for you. Thank you for a brilliant presentation. So I was interested, in more technical, perhaps details. So did you try to degrade the quality of the F1 score, by running ablation studies and all this stuff, just to see how it drops, given different factors that can make it worse. Also, I like the idea about that these systems need to be embedded. This model needs to be embedded into certain system, right? In order to collect additional data, you actually need to make the model more precise. So it's more, I think, also about embedding these models into some, data systems that would provide more kind of, sources to increase the precision of these models. It's kind of, in a way, it makes it kind of, it's closed, right? Yeah. And just a small remark about the sentiment analysis. I think you try also to bring together, I think, AI detection and also the sentiment kind of, the sentiment analysis part, which was also interesting, I think, because I thought, okay, ChatGPT, the OpenAI actually does this part of the job in a way, but might be not necessary, but yeah.
Yeah, just on the note of the sentiment analysis thing, it's if ChatGPT has a very specific style and it always is somewhat agreeable, somewhat neutral, sentiment, or positive, never upset with you for asking the question, never moody, then this means that if you are neutral tone and you are very agreeable, that you actually are at a higher risk of being labeled as a false positive because you just happen to be like ChatGPT in personality, and that's bad. So obviously the problem gets very complicated with more and more factors. But and then to your point about the F1 score, which specific paper were you talking about? Is it just the RAID data set, the text detection, or the Mirage News?
I think the Mirage News.
Yeah, so we had a bunch of ablation studies in the appendix of the paper where we removed the concept bottleneck. We did early fusion versus late fusion for the sort of image and text and tried to see which one of them was the best. One of the results that we found is that it seems like there's a big difference between the classes of images in terms of accuracy. So when I say that, I mean concept bottlenecks do really well on the real images, and the linear layer embedding does really well on classifying fake images. And I'm not entirely sure that I have a good intuition as to why that's the case, but that could be one reason. As when you're combining them, they sort of they both benefit from each other. But we found that there's different parts of the pipeline that are doing different things, but all of the different components do go into the final accuracy score.
And so you are mostly working on supervised learning world.
Yeah,
so
that's right.
Therefore, F1 scores are so high.
Yeah, right. In the in-domain cases, they're very high, and then out of domain cases, they were still fairly high, But again, it's the same exact generation pipeline where I take GPT-4, I generate a misleading caption, and then generate the image. If I did anything else, like this is a very sort of easy out of domain case. The only thing I changed is the generator. You could change a myriad of different things if you wanted to. So.
Cool. So I just wanted to mention that on what happens with when training data is a problem, that would be partially subject of our next seminar, where Matthew will speak on model collapse and on detection, particularly in video, audio, and image space. Meanwhile, I think your presentation was optimistic, at least in certain cases, and
that's optimistic.
Education, for instance, one that a lot of people here care about. So now I think we can thank Liam for excellent presentation. I think we learned a lot.
Thanks everyone for the really great discussion. It was awesome. Your questions were very, very good. So. Cool.